Okay, so this is my new m now, this is my new n. Now let's take the partial of our new m with respect to y. Okay? Okay, we get basically a 2y in there, so it's minus 2x squared y sine of x. Differentiate that by respect to y, you get a 4yx cos x. Right? Partial respect to y. Okay. And now let's take the partial of our new n over here with respect to y. Okay? And with respect to x. Right? Differentiate respect to x, okay. I pull out the y, I'll pull out a 2y, okay? And now I've got to differentiate x squared cos x using the product rule. So I get minus x squared sine of x plus 2x cos x. Right? Pull up 2y, x squared times negative sine, cos times 2x. Okay, now let's compare, okay? We got two terms. I got on the left over here for dm dy, minus 2x squared y sine x. There it is, minus 2x squared y sine x. And the second term over here has got 4xy cos, and there's your 4xy cos x, right? So it's exact. So now the partial of m with respect to y, the new one, equals partial n partial x. So it is exact. Okay, and again, I've been using the same letter over here. You realize, of course, that this m and this m are different. You may want to put something different there. So I say when I'm doing this, it's the new m that we multiply through the integrating factor. Okay, so now we know that this equation is exact. Let's go and find the solution. And this would be the third part of the problem. You know, first thing would say, show it's not exact. Second part, show that this, whatever it is an integrating factor. And then once, the third part would be what? Well, I have the integrating factor, you know what to do. It'll say solve the equation then. Okay, so let's do that. Okay, so there's my equation that's exact, okay? It's kind of a little messy, okay? So I know there's the function u of xy whose total differential is equal to that, so you show that it's exact. So du dx is equal to the dx coefficient, so that's minus x squared y squared cosine of x, not sine of x.
It's partial u partial x or partial p partial x?
Say that again, please.
Is it partial u partial x or
Yeah.
partial p?
Partial u, partial x, or?
Or partial p partial x?
No. Partial,
Like-
what is it, phi?
Yeah.
There's no phi here.
No,
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 we're not up
just-
to that yet,
Ah.
okay? Basically, okay, this is exact, right? So therefore, it's the total differential some function u. And you know what du is? It's partial u partial x dx, partial u partial y dy. So in du dx, I gotta match the dx coefficient. So it's minus x squared y squared sine x plus 2y squared x cos x. Okay, let's just check that again. Du dx minus x squared y squared sine x plus 2y squared x cos x. Okay? And I also know that the partial u partial y is the dy coefficient. That looks much smaller. 2x squared y cos x. 2x squared y cos x. Right? Use the dy coefficient, that's going to be 2x squared y cos x. Okay. I think, you know, I'm going to do the second one. Less terms to integrate. Doesn't make a difference. No? If I integrate the last one, remember I'm integrating partial with respect to y. So make believe x is fixed. Into y squared over 2, so that becomes x squared y squared. Right? Cos x. Plus some arbitrary, here comes the arbitrary function. Arbitrary function now of what? Of x. Let's check this. Let's take the partial view with respect to y. the derivative of y squared is 2y, that's going to be a 2x squared y cos x, right? Keeping x fixed. And then the derivative with respect to y of phi of x is 0, right? Because it's a partial respect to y, it's only a function of x. Okay, now, so that was integrating that. Let's get partial u partial x now, because we haven't used that. It's going to be a little bit messy, and then we'll have to equate the two. So from what I just obtained, partial u partial x must be the following. It's got y squared in there, okay? And now let's use the product rule on x squared cos x. So first you get a 2x cos x, right? Then a minus x squared sine x. Plus phi prime of x. And check that again. That's clearly phi prime of x. I pull out the y squared and I differentiate product rule x squared cos x. I get 2x cos x and minus x squared sine, right? Straightforward. Now be careful. You should kind of review, go back and check yourself. Okay. But partial u partial y must equal what? 2x squared y cosine of x. From there. Okay? And great. Now when I equate these two expressions, the two, where did I get x squared y? Okay. Fine. I made something with the power got screwed up. This is why it's good to do this. You see what I'm saying? Okay. Where did I make a mistake over here?
Wouldn't it equal the first equation?
Oh, yeah.
That's right. Partial u partial x, thank you. Yeah. I'm so used to doing the other one. That's right. Partial u partial x, the first equation. So you get minus x squared y squared sine of x plus 2y squared x cos x. Thank you. And now when I equate the two, on the left I got a 2xy squared cos. Yes, 2xy squared cos, so those guys go out. Here I get a minus x squared y squared sine, minus x squared y squared sine. So in this case, it's very, usually we get phi prime of x is some function of x. Now phi prime of x is equal to 0, which means, of course, what? Phi of x is a constant, right? Okay. So now the solution for u is x squared y squared cos x, right? Plus an arbitrary constant, but I'm going to set it equal to a constant anyway. So the phi of x basically I can ignore. And the solution to the differential equation is simple. It's x squared y squared cos x equals c, where c is an arbitrary constant. Let me just check that. X squared y squared cos x equals constant. Yes, that's right. Any questions on that? Okay, so now we basically covered everything that I want to on exact and inexact equations. Okay, let's talk about the test for a bit. Okay, I gave you, the chapters that responsible for. Okay, and kind of when you kind of survey the whole thing, let's go back all the way from the beginning. What did we really do? We talked about differential equations and linear, nonlinear. Okay. Then we did, first thing that we really did, what was new, was autonomous systems, autonomous equations, right? Where you had dy dx as a function only of y. And the type of exercises there are things like you'll be given an autonomous equation, right? It'll say, to find, you've got to find equilibrium solutions, and then there'll be a question something like, they'll say sketch, a typical solution curve in every region determined by the equilibrium. And remember what I said before, students tend to put too much, okay? What happened typically was what? Example, there was, say, two equilibriums. So here's your XY plane, right? Maybe here was an equilibrium solution and here was another equilibrium solution, right? So there are three regions you have to worry about. You have to draw a curve over here, some curve over here, and another curve over here. Not necessarily the way I drew them, right, based on the slope. So don't draw like a whole bunch of curves in each region, okay? So in each region, determined by the equilibrium, you just need one representative curve, okay? Because they're all kind of the same. And of course, you know how to do it because we have all those rules we established, how the derivative is only one sign, and that it can't be multi-valued, okay? Now, of course, I realize you're doing this by hand, but try to be as neat. So I recommend doing this with pencil rather than ink, okay? And, you know, my handwriting isn't the best in the world, but at least indicate if it's asymptotic. I mean, what some people have done in the past, they'll do things like this, right? I can't give full credit for that, right? I want to see something where it's basically asymptotic to here and comes down like this, okay? So, you know, try to draw the graphs, you know, pretty clearly like that, okay? And then we did classification. You know, is it stable, semi-stable, or unstable, right? Okay. So those are all just definitions. That one's pretty easy, right? Then the next big topic we did was first order linear equations, right? Remember that was basically the prototype was dy dx plus p of x times y is some function of x, right? Okay, and yeah, there you do have to memorize one little thing, right? You have to remember to always get the coefficient of dy dx equal to 1. So if there's like an x cubed in there, you'd have to divide through. And then what do? The integrating factor was very simple. It was the exponential of the integral of p of x dx, okay? And that made it exact, and you know, you have checks along the way because what should be is that after you multiply this thing through by the integrating factor, the left-hand side should be d by dx of the integrating factor times y. What I suggest that you do is, although in theory we know that has to be, in your mentally, do the product rule in your head to make sure that you didn't make an algebraic mistake. And then you just integrate both sides. Okay? And then maybe an initial condition, right? Solve this first order subject to the condition that it goes to the point x equals 2, y equals 7, or something like that. Well, we know what to do. We get the general solution. There'll be an arbitrary constant in there. We apply the initial conditions. We get the value of c. Okay. Now, another thing which, and I'm very, you know, you have to be very careful about this, and I'm very specific on the exam. Some problems will say find a solution. Some you'll see says find an explicit solution. And you'll see in parentheses y is a function of x. We saw that in certain cases like here, no, not this one, but we had ones like, you know, either y, stuff like that. There's no way of solving for y in terms of x. When the problem says find an explicit solution, I want you to isolate y equals and put all the x stuff on the right. Okay? May require a little work, but that's what, and you'll lose credit if you don't get the explicit solution. Okay? If I don't say get an explicit solution, then you can just leave it like, for example, leave it like this. Okay? Okay. So that's first order, so we did autonomous, first order linear. Okay, and then what do we do next? Let's do something else. Before we did exact. Oh, we did separable. That was even easier, right? Separable equations, right? Okay, so you look at dy dx, and okay, and if it's just the product of a function of x times a function of y, or can be factored in a form where it's a function of y, then that's basically, you know, a freebie almost, right? No new technique over there. And then there's the exact stuff, right? And again, I'll probably have one problem where it'll, you know, I'll just say, you know, find a solution, okay? And you know already, as soon as you see nonlinear stuff in y, we haven't done any nonlinear equations except for exact. So you'll say, oh, it's probably exact, and then, you know, do the usual test, you know, dm dy, dn dx, okay, integrate, okay. There's a, you know, quite a bit, sometimes there's quite a bit of work in doing this thing, you know, when you have to do, you know, these integrals. And again, don't forget that arbitrary function, okay. If you choose to integrate du dx, partial u partial x equals some function of x and y, you get an arbitrary function of y, right? So depending which way you do it, the arbitrary function could be a function of y, function of x, okay. And again, that little thing I told you about, that when you get that, say, phi of, like over here, we got a phi of x, and we got the phi dx equals, if there's a y in there, you made an error. And I'll give you more credit if you actually recognize that they go on and integrate partially, because that gets me very frustrated, okay? Right, test basically on is the concepts and stuff like that. Actually, it may sound ridiculous, but the answer to me is the least important. What's important is that you follow logical steps, and your reasoning follows from one thing to the other, okay? You make an algebraic mistake, sometimes I'm going to take off any credit, okay? And what I do is I'm fair in the sense that if there's a multi-part question, part A, part B, where unfortunately say part B depends upon part A, you can get full credit on part A if you got part sorry, you can get full credit on part B even if you got part A wrong. What I'll do is I'll take your erroneous result and propagate the error through, and if you're interested in more errors, then you'll get full credit. Okay? That's just, I don't think it's fair because you made a sign error in part 1, and then of course you can get part 2 wrong. But again, it's the concept that's important. Okay? And again, I'm not going to have any crazy integrals. What happens many times is that a good one is something like this, right? Many times people forget they may have something like this. They may have like x cubed dy dx plus the sine of x times y equals, I don't know, e dx sine x. I'm just pulling this out here, right? And then they say, oh, p of x is sine x, and they integrate. Then they get an integral that's impossible, and they come up to me, I can't do this. And yeah, he lied to us. He said there's going to be any bad integrals on it, right? But if you divide it through by the x cubed and you did it right, you should not encounter any bad integrals. So that's kind of an indication, kind of like if you're getting some things with weird integrals, you probably made an error someplace, okay? So, but again, I do expect you to know things that we've done in class and even things that we haven't done in the sense of, integrals of sines and cosines, exponentials, the product rule, we've used that many times, and integration by parts, right? Yeah, I know that, okay? Okay, so details, okay? There's basically going to be 5 problems, okay? 20 points each, right? And, before I go on, let me tell you also things when I sent out these kind of protocol, as I call it, for the exam, okay? I cannot give you the exam if you don't come to class with an ID, okay? Because today's a little different, but usually about half the people show up. I don't even recognize half the people when the exam comes, okay? I've never seen them before except maybe on the first day, okay? So I have to have a way of verifying, it's not perfect, that the person who's taking the exam is actually the person who's registered for the course. So please have, a good photo ID. It can be a driver's license, a CSUN ID, I don't care. And I have proctors here that will be checking that, okay? And like I said, this is just unfortunate because of this, cheating that has gotten to, really out of control. I have to do things now which I usually didn't do. Usually I let people have open book and stuff like that and bring in notes, but it's just, it's just too risky, for lack of a better word, okay? And I think I talked about this the first day, how people, what they do with the cell phones,